So here's our beam. And it says that the beam is supported at both ends. So I'm thinking it's got legs underneath. And there's a piano that's 1/4 of the way from one end to the middle. So this is, the whole length here is L. Then this right here is L over 4. Does that make sense? And they want to know the forces being provided by the two supports. So let's redraw this as a torque diagram. There's my beam. I'm going to draw the force vectors in. I've got the right support over here, the left support over there. I have here mass of the piano times gravity. And then right in the middle of the beam here, right there, I've got mass of the beam times gravity. And they want to know the right force first and then the left force second. So since I've got forces, I'm going to do a force balancing equation just like it was a free body diagram. I'm going to do L plus R, those are the two upward forces, minus m sub bg minus m sub pg. Those are all my forces. Up ones are positive, down ones are negative. And that has to be equal to 0 because it's not moving. Well, once again, I see that I'm trying to find L and I'm trying to find R, and they're both in one equation. That's not enough information. So although I might be able to use this later, I'm not going to use it now. I'm going to have to go to torques. And I see my problem is that L and R are together in the equation. I need to do something with torques that's going to get rid of one of them. So I'm going to carefully choose a center of rotation that's right on top of one of these two forces. It doesn't matter which one, but I usually do the one on the left. So my center of rotation is going to be there, so that way this force is going to have no torque because it has no lever arm. So I draw in the rest of my lever arms here. This one here that goes with mass of the beam times gravity, that's going to be 1/2 the length of the bar. This one that goes with mass of the piano times gravity, that's 3/4 of the length of the bar. See, because it said it was 1/4 of the way this way, so that means that this whole length here is 3/4. And then the last lever arm, the one that goes with the right support force, that's the whole length L. Then I go and do my angles. Well, they're all 3 right angles, so that makes it easy. And now I can write a torque equation from this. Remember, what I'm writing is that the total torque is equal to 0. I have 3 torques, 1, 2, 3. 2 of them are tending to pull the beam downward, so I'm going to make those the same sign. I think I'll make them both positive. And then this one is pulling the beam upward. I'll make that the opposite sign. That'll be negative. So the first one is 1/2 L. That's the lever arm for the first one, times mass of the beam times gravity. Then the second one is 3/4 of L, mass of the piano times gravity. And the last one is the negative one, negative LR. And I realize I've just used the letter twice in the same diagram. So I'm going to change this force here that I called L before. Let's do. Let's change all of these to lowercase l's. And then we won't get so confused. So these are all lowercase l's, and then these will all be, these will all be lowercase l's. Then I won't have 2 of the same thing in my equations. There we go. So now I can actually factor this lowercase l out of this whole equation, and I'm going to have 1/2 m sub b times gravity plus 3/4 m sub p times gravity minus the right force, and that has to be equal to 0. And look, I can divide both sides by L. It's okay to divide by a letter as long as you know it's not 0. And and it goes away. And that will lead me to the right-hand force is going to be equal to 1/2 mass of the beam times gravity plus 3/4 mass of the piano times gravity. So once I've calculated R, I can just stick that into this equation with all these other things that I know and calculate the left-hand support.